So this is our second lesson on combining functions, and this time it's about multiplying and dividing. Very similar to last time. Again, I want to show you a little problem of where we need to use this. So, tired of teaching, Mr. Anusik starts a t-shirt business. At $20 a shirt, he sells 104 shirts per week. Not too shabby. After some research, he finds that if he charges $3 more, he loses 8 customers. So what's the function that represents the number of customers in terms of the number of increases? So I'm going to say let x represent the number of increases. So that means n of x is 104 minus 8x, because every time he increases his cost, he decreases his customers by 8, and he started at 104. So 104 minus 8 times the number of increases. Okay. How about the cost per shirt? Well, the cost started at 20 and it goes up by $3 every time he increases. Right? So that means he's increasing his shirt cost by $3. He's decreasing his customer base by 8. All right. So finally, what's his revenue? Well, revenue we know is cost times the number of sales. Well, cost is C of x and sales is n of x. So that means that his revenue is 20 plus 3x times 104 minus 8x. And that's it, right? So what we did was we had to multiply 2 functions to get the revenue. We had to multiply the cost function times the number of sales function. All right, so let's see mathematically how we do this. Very, very similar to adding and subtracting. So for product, we multiply the y values. For quotient, we divide the y values. And that means f times x, we can plot x times f times g. And quotient, we can do f divided by g. Okay? So again, we'll plot 2 functions. So here's the first one, x plus 2, and the second one is going to be x squared plus 2x. So there's x plus 2, and then x squared plus 2x looks like that. And I've filled in the f's down here, just like in the last one. So I want to look at the table of values, and the g is going to be that. And now f times g, I'm going to multiply the f and the g. So there's my f times g column. And then we're going to plot those points. So there they are. I'll draw my curve of best fit. So that's what f times g looks like. And that kind of makes sense because f times g is just a quadratic times a linear, which means a cubic. So that makes sense. What about f divided by g? So there it is. And now we need to plot that. Oh, we haven't plotted it. Okay, so to plot this is going to be a little bit more challenging. But f divided by g, remember what that looks like. So f divided by g. And g I'm going to factor. So there's f divided by g. And now we remember from our rationals that we can cancel this out and just say that it's 1 over x, but with a whole at -2. So that makes sense because at -2 it's undefined and at 0 it's undefined. So that works. And now we can just go ahead and make a rough sketch. So this is there. And then 1 over x just looks like this and like this, but it's got a hole at -2. So that's basically what that graph would look like. We could also, instead of doing this, we could have also done a more specific table of values, and that would have worked out as well. Okay, so let's look at algebraically getting f times g. So we just multiply the 2, expand and simplify, and we're done. So it's a cubic, which makes sense because that's what our graph looks like. And f divided by g, all we do is put f over g and then factor, simplify, and this is what we end up with, 1 over x, but with a restriction. X is not equal to -2. Okay, so there's that. So again, just multiplying the y values or dividing the y values based on what we need. So the domains, again, are the intersection of both. Okay, so again, these are called combined functions. And the domain of f was x and r, and the domain of g was x and r, but the domain of g was also that x, oh sorry, no, yeah, that was fine. And the domain of the division was that x is in r, but x is not equal to 0 and -2. Right? So not equal to 0 and -2 because g was in the denominator. Okay. So here's another example. I'm going to let you do this one yourself. And now let's look at this. So if we want to do f times g at -2, all we need to do is f at -2, calculate that. G at -2, calculate that, and then multiply the two, and we get -20. Or we can do f times g is f times g, expand, collect like terms, and now plug in -2. And what we get should be the same thing. And once we simplify, it is. So that's good. So that's multiplying functions. You can do the dividing example by yourself. It'll work the same way.